Hello everyone, today we will discuss pass transistor, and pass transistor is the logic in which we use a single transistor to pass the supply voltage. So let's take NMOS as a pass transistor. So NMOS, we know that it is a good, uh, it is a strong 1 0 pass transistor, and bad for passing 1. Okay, so if I am giving here VDD, and I'm giving here VDD and then VC I am checking, so this will give VDD minus VTH at output. Why it is giving like this? See, for switching on this NMOS, the VGS must be greater than equal to VTH. Okay, so if my VGS is this this capacitance voltage, this is source and this is drain, I will take. Okay, so VGS will be equal to VDD minus VDD minus plus VTH. Okay, so this is equal to VTH, so this is equal to this. Okay, so the transistor will be on up to this. If I am reducing more this, I am increasing this more, this VC. Okay, so that what will happen, this will reduce. Okay, so my VGS is equal to VTH I am getting for now. If I am increasing this more, means how can I increase it? By decreasing it more, this okay, so my this VGS, total VGS will reduce, and this will reduce more than this VTH. My transistor will be off. Okay, so for example, let's take some value. I'm taking VDD equal to 5 and this is 5 volt, and VTH I am taking 1 volt. Okay, so what is my VGS? So to on this transistor, VGS must be greater than equal to 1 volt. Okay, so what is VGS? VGS is equal to 5 minus 1, sorry, yes, 5 minus this 4 volt. Okay, this should be 4 volt now. This is 5 minus 1 equal to 4 volt. Okay, so this should be, so how much I am getting? 1 volt. Okay, so you can see that this 1 volt is equal to this. Okay, so my transistor is on. If I am increasing it more, let I am increasing it 0.1 volt more, let it is charge up to 4.1 volt. So what will be my VGS now? VGS will become 0.9. so you can see that it is less than the VTH value, right, which is 1 volt. So my transistor will be off, so my capacitor can charge up to VDD minus VTH. Okay, so this now, see the condition for charging this for transistor will conduct up to 1. What? When my VGS is greater than equal to VTH, up to that time my transistor will conduct. Means what? VG minus VS greater than VTH. Okay, or we can say that VS less than equal to VDD, that is VG minus VTH. Okay, and the VG I am taking VDD, so VS must be VDD minus VTH, up to which this condition my transistor will conduct only. Okay, now let's suppose I am at the drain side, drain terminal, the voltage VD is less than VDD minus VTH. Then what will happen? Then obviously there will be no current flow any further after the source charge up to the drain voltage. Okay, now let's understand this by an example. So see, I am taking here this like this. I am taking a NMOS pass transistor, and I am taking here VDD, and here I am taking 2 VDD. Okay, and VDD I am taking 5 volt, and there it will become how much? 10 volt. Okay, and VTH I am considering 1 volt. So how much it will charge? It will charge up to 5 volt. Okay, see, which I should told. so it will charge up to this VDD, up to the drain voltage it will charge. Okay, and if I am giving there also 2 VDD I am doing, and so it will become how much, 10 volt. Okay, so it is become 10 volt. So how much it will charge, it will charge up to VDD minus VTH. Okay, VDD minus VTH, which is equal to 9 volt, because if it is charged up to more than this 9 volt, VGS will become less than VTH and my transistor will stop conducting. Okay, so this is now, so generally uh, how can we write this, what is the voltage on this source terminal? Generally we can write it like VST equal to minimum VG minus VT comma VD. Okay, by this we can see, this is a general way to express it. Okay, so now take an example, and that is this is VDD. Okay, VDD, and again I am giving VDD, and there it is also VDD, and VDD is 5, VDD I am taking 5 volt, VTH I am taking 1 volt. Okay, so it is 5, it is 5, this is 5. So how much voltage I will got here? We know that it will be VDD minus VTH, which is equal to 5 minus 1, that is 4 volt. Now what will be the voltage across it? 4 minus 1 equal to 3 volt? No, it's wrong. It won't be. It will be only how much? 4 volt. Why it will be 4 volt? You can see that, see VGS, how much it VGS? VGS equal to 1 volt. Okay, so 1 volt is equal to how much? VTH. So it is conducting. If I am increasing it more, okay, 4.1 I am doing, then my VGS will become how much? It will become 0.9, which is less than VTH. Okay, so it will, see, you can see that it is charged up to VDD, sorry, this drain voltage. Okay, VD. Okay, so now see from this formula also you can see that VST will be become minimum. Okay, what is VG? VG is 5 volt minus VT, VT is 1 volt, and drain voltage is 4. Okay, so it is 4 volt you will got here. If I am doing here how much, 3 volt I am making. Okay, okay, if I am taking there 3 volt, then what is the voltage on this side? It will be 3 volt. Okay, see how by this formula if I am looking, this will become 5 minus 1 and this will become 3. So what is the minimum? 3. So 3 volt. If we are looking by this way, and you can see by that way also that VGS is equal to how much? 2 volt, and it can't charge further because on drain side it is the supply voltage only 3 volt. Okay, so, and now take some more example. This is VDD I am giving here 5 volt, and on this side 5 volt I am giving, and this is controlling this another NMOS, and there it is 5 volt. I have to calculate voltage on this terminal. Okay, so at terminal S, voltage at terminal S equal to question. Okay, so see at this terminal what will be the voltage? Voltage will be VTH I am taking 1 volt. Okay, so it will become Y minus 1 means 4 volt. 4 volt is coming to this drain side. What will be the source voltage? Okay, the source voltage will be how much? It will be 3 volt. Why it is 3 volt? See, 4 minus 3 VGS. Okay, it is equal to how much? 4 minus 3 equal to 1 volt. Okay, more than this it can't charge, because if it will charge more than 3 it will become less than 1, means less than VTH. So this transistor will stop conducting. So this is the problem. so it will become 3 volt. Okay, now let us consider this is 2 volt. Okay, now what will be the voltage at the source side? It will be 2 volt. Okay, see, VGS is equal to how much? VGS is equal to 2 volt, which is greater than VTH, so it will conduct, but it can't go more than this 2 volt because at the supply, which is at drain terminal, is 2 volt only. Okay, so now let us consider one thing, that I am giving a inverter on this. Okay, sorry, inverter I am giving. This is PMOS, this is VDD, and this is NMOS. Okay, and there it is output. So see, on if I'm if this 2 volt drive an inverter, then the NMOS, this NMOS gate value of the inverter is still considered high. See, this 2 volt is still high for this. Okay, this transistor will on, but the problem is what, you know that ID is directly proportional to the VGS minus VTH. Okay, if square, okay, for current equation, if my VG equal to VDD, so this will be VDD, S is equal to 0, so it is VDD minus VTH square. Okay, ID. If I am keeping this VG at 2 volt, VDD was 5. Okay, so it was 5. If I am keeping this as 2 volt, then it will become 2 minus VTH square. 2 volt you are taking, then you can see that current is reducing. Okay, ID is reducing. So by this you can see that switching characteristic will be effect. Okay, so this is the problem. Okay, so while designing any circuit, you have to keep in mind that one must not drive the output of the pass transistor as an input, okay, to the next transistor. Okay, if you want to use this output to the, okay, if you want to use this output of a pass transistor to drive any another circuit, then use between them some inverter, so it can drive its value, original value, and then you can give. Otherwise don't use this. Okay, so thank you. This is all about the pass transistor. Thank you.